This video is about modeling a closed-loop system. There are two main approaches you can take to model a closed-loop piping system. If we look at option 1, we've got a reservoir node in line with all the other pipes and fittings in the system. This node allows us to assign the fluid's pressure and the associated temperature to the actual model itself. In this model, we've got a pump which has been automatically sized based on the design mass flow rate of 5 kilograms per second. We've got 5 degrees Celsius temperature coming out of the network of the stage. Then, we have another 5 degrees Celsius temperature being added back into the network. At this point, we have a shell and tube heat exchanger before the fluid then returns back to the reservoir. That's one approach you can take to model a closed-loop system. Another approach is to actually split the model in the location of the reservoir and use two non-pressure boundary elements. If we just look at this reservoir, you can see that there's a liquid level associated with that. We've got 1 meter of liquid. If I look at the connections, you can see the pipe connection to the tank is at the bottom. So you've got a meter fluid head taken into account where we have the reservoir. If we look at the known pressure, we have set it to 1 meter fluid gauge. It's taken into account that we have a meter of fluid, a temperature of 15 degrees Celsius, and we've got water. If we just look at this boundary, it's the exact same design condition, except the fluid in that case is defined as air. This actually doesn't matter. That can be set to any fluid at all. It can be left as the default water setting. It doesn't matter because the fluid is what you viewed in the Results tab. And this is an assigned fluid. Remember, the boundaries known are assigned pressure. That just means in that case its known information is the input. Whereas in this position, this is actually the outlet. So the assigned value you want to look at is the results. But the design condition, pressure-wise, is the same nonetheless in both cases. We've got our pump with 5 kilograms per second, our heat exchanger with 5 degrees Celsius temperature change, and the results are identical essentially in both cases. Sometimes, with new users who are not that familiar with the software, when they want to model a closed-loop system, they place a boundary, or a reservoir, outside of the main closed loop itself. This won't work because it always needs to be in line, or the model splits. What you're drawing there is that scenario because this is essentially the same thing. You can see there are lots of warnings associated with that particular model. But if I right mouse click and delete that, swap by clicking the right mouse, and selecting swap this connector node for a reservoir. Then, recalculate. Those warnings will disappear as simple as that.